Next point is resolutions. So mapping a name to an address or an address to a name. First, in host, we assign the host name and the IP address. So the mapping is required for DNS. For example, XYZ system is there, and that XYZ system that is to be assigned by IP address 132.34.45.121. So in DNS, what happens? That DNS server will be resolving that host name with that IP address. Now, resolver is what? A host that needs to map an address to a name or a name to an address. So, mapping names to addresses are what? Resolver gives a domain name to the server and asks for the corresponding address. So, server only checking that country or the generic domain for its mapping purpose. So, mapping that addresses to that names, uh, how it will be mapped at client generally send an IP address for mapping a domain name and it use the inverse domain. Now the resolver first inverse IP address and then adds the two labels before sending. So generally that DNS, where is the DNS actually located? Uh, Last time I had also discussed with you that DNS will require some ma- that DNS mascoding where that host that open source that host file where that in that host file that host name that is to be mapped with that IP address. Now that DNS has the that locally we can also assign that DNS. Now, so suppose one organization is there. For one organization, we can take the DNS server, and in that DNS server, uh, whenever that client system want to access that domain, so that time we require some primary and alternate DNS, primary and secondary addresses. So here that is used for the resolving purpose. We can also use that global DNS, global DNS, or that service provider is also providing that DNS, primary DNS and secondary DNS. So now here client sends here how actually that working will be there. That client generally sends that uh, resolver. Resolver send query to the server and it checks the database and respond. If we do not have that domain name, then that will forward the query to the another server and so on. So first of all, this is the client and this is the fhda.edu. Then just for resolving purpose, it again goes to the edu server, then the root server. And if it is not available here, then it again navigated to that form, then again macro.com, and then it will be responding to that client system. Suppose that system is getting that specific domain, that time it just responding. Okay, so that that way that DNS will be resolved. Now client are repeating the same query to the multiple server. Now see here the client is there. That client there are multiple server. That .com server is also there. That root server is also there. edu server means different. There is different server. It just sending the multiple queries to that multiple server. And if the server do not have the domain name, then if the domain name is not available in that server, so what happens? The IP address of the server that it thinks can resolve the query. Now, caching is what? When a server asks for a mapping from another server and receives the response. Now, it stores the informations. Many times, what happens? Suppose if I'm searching some URL and multiple times, that time what happens? The local cache will be available in that open source. What happens? That local cache that is to be located inside the local server. Instead of going to that or navigating to that remote server, it just resolving that things locally. So because of this, what happens? Whatever the time is required to for going to that remote server, that is to be resolved. अगर सपोज मेरा वही सिस्टम अगर मुझे लोकल में अवेलेबल है, कोई एक साइट है xyz.com, तो वो साइट अगर मेरे लोकल कैश में अवेलेबल है तो वो क्या करेगा, वही कैश से वो रिट्राइव करेगा। तो मुझे एक्चुअली xyz.com पे जाने की जरूरत नहीं रहेगी, वो मेरा लोकल सर्वर ही उसको रिजॉल्व करके आंसर दे देगा। तो इससे क्या होता है, हमारा टाइमिंग हमारा कम लगता है, जो भी हमारा राउंड ट्रिप टाइम रहता है नेटवर्क का, वो हमारा अ, कम लगता है इस तरह। So DNS messages are what? DNS has two types of messages. So one is the query message and another is a response message. And both types have the same format. The query message consists of a header and question record, and the response message consists of a header and question record. So here is the format. So query and response messages. So query message has a header and question section, and for a response section, what happens? That's the same things are here, header and question section. But here, what are the answer section that is to be appended here? Authoritative section, additional section. तो ये एक्स्ट्रा सेक्शन हमारे रिस्पॉन्स सेक्शन में आता है। मतलब जब भी क्लाइंट हमारा क्वेरी भेजता है तो खाली क्वेश्चन भेजता है, बट रिस्पॉन्स के वक्त क्या होता है कि जो भी हेडर और क्वेश्चन रहेंगे वो एज इट इज रहता है, और उसके साथ वो आंसर्स को भी एनकैप्सुलेट कर देता है, और वहाँ पे ऑथोरिटी सेक्शन जिसने सेंड किया है वो ऑथोरिटी सेक्शन को ही वो सेंड करता है। तो both query and response message has have same header format of size 12 bytes, तो 12 bytes का वो साइज रहता है। तो रिकॉर्ड के टाइप कौन से हैं? टू टाइप ऑफ रिकॉर्ड्स आर यूज्ड इन डीएनएस, जैसे क्वेश्चन रिकॉर्ड रहेगा और रिसोर्स का रिकॉर्ड रहेगा, ऐसे दो टाइप के रिकॉर्ड होते हैं। तो how are new domains added to the DNS? This is done through a registrar, a commercial entity accredited by the internet corporations for assigned names and numbers. So encapsulation is what? DNS can use either UDP or TCP. DNS कोई भी एक ले सकता है कि can be used either UDP or TCP. In both cases, the well-known port used by the server is port 53. Now UDP is used when the size of the response message is less than 512 bytes. Okay? Whenever that message size is less than the 512 bytes, that time UDP is used. Uh, most UDP package have a 512 byte packet size limit, and if the size of the response message is more than 512, that time that user TCP, which is the connection oriented. Now DNS can use the services of UDP or TCP, that using the port number 53. So next the point is what? HTTP.